we have the integral from e to e squared of 1 over x ln x all squared dx. So we can use the notion of antiderivatives or u substitution. So if we just let u to be ln x, the derivative of u is 1 over x dx. So then we substitute that into the original equation, and then we would have the integral of 1 over u squared. Take the inverse of that. It means we're trying to find the inverse of the integral of u to the power negative 2. This would be u to the power negative 1 over negative 1. Now, we substitute u back into our final answer and we get negative 1 over natural log of x. Putting in our limits, which are e squared and e, we would have negative 1 over 2 plus 1, which is equal to a half. Question number 20, we have the integral of e to the power x plus over 1 plus e to the power x, Okay, for us to integrate this, we will let the denominator be u. So if u is 1 plus e to the power x, therefore du by dx is still e to the power x. Okay, we can see that we are using the notion of basic antiderivatives here. So in this case, if we substitute each of the values, the e to the power x would cancel out and we have just 1 over u left. The integral of 1 over u, once again, is natural log of u, and then we replace u again and we have our final answer, ln of 1 plus e to the power x plus c. There we go. Question number 28. We have the integral of square root of x e to the power 2x squared x. So if we take a look at the power 2x squared of x, we can see that they have common bases. We can simplify using the law of indices. So if we let e to the power 2x squared of x be equal to u, then we simplify it. It will be 1 plus a half, which is basically 3 over 2. So that will be e to the power 2x to the power 3 over 2. Now, if we differentiate this, we would have 3x to the power half e to the power 2x to the power 3 over 2, which is basically 3 square root x e to the power 2x square root x. Like I said, I can explain differentiation in another video. So now we replace this value back into the original equation. We would see that the integral of square root of x e to the power 2x squared x dx would be equal to integral of square root x e to the power 2x squared x du all over 3 root x e to the power 2x root x. Now it's going to cancel out nice and neatly, and then we're just going to have 1 over 3 left. So the integral of 1 over 3 is 1 over 3 u plus c. Then we replace back the value of u. This will give us 1/3 e to the power 2x square root x plus c. Question 29. We have the integral of x e to the power 2x plus 1 dx. So if we let u be equal to 2x plus 1, this would imply du by dx is equal to 2. Now that would simplify the function for us, but then we'll still have x in the beginning. So I think we might need to use integration by parts. Okay, so if I replace the value of u, I'm going to have integral of x e to the power u du over 2, just like I said. And If now s is equal to x and dt is equal to e to the power u, which is integration by part, ds over dx equals to 1, and then t will equal to integral of u, e to the u, which is still e to the u, right? Now, substituting the formula for integration by parts, this would be st minus integral of t times ds over dx. Substituting each of those values, we'll have half times x e to the power u minus integral of e to the power u, which is still e to the power u. We are going to replace our value of u, and we get our final answer, which is half x e to the power 2x plus 1 minus e to the power 2x plus 1. We have the integral of x e to the power ax. Okay, so we're going to let u to be x and e to the power ax to be dv so that we can integrate it later. Okay, this would be du by dx, which is 1, and then v would be the integral of e to the power ax, which is 1 over a e to the power ax. So the explanation is, if t is equal to ax, then dt by dx is equal to a, and dx is equal to dt over a. Obviously, we use a change of variables, and we will get integral of e to the power t dt over a, and finally 1 over a e to the power ax as v, right? Now we're going to substitute into the formula, and we should get our answer, x times 1 over a e to the power ax minus integral of 1 over a e to the power ax dx. Okay, if we're focusing just on the right hand side of the equation, which is the integral of e to the power ax, we would see that the 1 over a would multiply each other to give 1 over a squared e to the power ax, right? Then we substitute back, and we'll get 1 over a x e to the power ax minus 1 over a squared e to the power ax. And our final answer should include a c. Question 43, we have the integral of 1 over x ln x dx. Okay, 1 over x dx is already the derivative of ln x. So if u is ln x, then dx is 1 over x. We can even group them together, like so. And then we replace ln x with u and integrate. That will give us u squared over 2. And our final answer will be ln x all squared over 2 plus c. Calculate the integral of ln x all squared dx. Okay, first of all, we are going to start by letting x to be e to the power u, such that the derivative will still be e to the power u. But if x is e to the power u, this would mean that we're going to substitute e to the power u to get ln e to the power u all squared. Now, the lateral log of e to the power u would just be u. So in that case, this would change to u all squared. Then we're going to get u squared times e to the power u du. So we've changed the variable, but now we need to use integration by parts to integrate this. So we're going to let s to be u squared and dt be equal to e to the power u. In that case, ds by dt is 2u, and then t will just be e to the power u, since when you integrate this, it still gives you e to the power u. Okay, so next up we substitute these values in the formula for integration by parts, and then here's what we get. Now we are left with the second part of the expression to work out, which is the integral of 2u e to the power u. Once again, we let s to be 2u and dt to be e to the power u. Remember, I said before in the first half of the video, you have to choose your variable in such a way that when you differentiate, its power is decreasing, right? So when you differentiate 2u again, its power will decrease and go to 0. So we have ds by dt, and we also have t equal to e to the power u. We're going to substitute this values, and this will give us the integral of u squared e to the power u as u squared e to the power u minus 2u e to the power u minus integral of 2e to the power u. That last part or last bit is very easy to integrate. It would stay the same as 2e to the power u. So now we are going to factorize the equation, and then we make sure that we plug in back the values of u. So remember, u would be ln x, so our final equation would be x brackets ln x all squared minus 2 ln x plus 2. Okay, number 55. So we have the integral from 2 to infinity of 1 over x ln x cubed dx. So if you recall, we have done a similar question in the easy or the intermediate section of this video. You can rewind if you didn't watch that part, where we saw the integral of 1 over x ln x by taking the idea that 1 over x dx is already derivative of ln x, right? Okay, but it's different this time around because we have from 2 to infinity. So we let u be equal to ln x. Derivative of ln x is 1 over x, and hence 1 over x dx is du. We go ahead and replace that in the equation with just the du. And we're going to have integral of 1 over u cubed du, which is the same as the integral of u to the power negative 3. And if you add 1 to negative 3, it should give you negative 2. So we divide all through by negative 2. Now we're going to have u to the power negative 2 over negative 2 from 2 to infinity. Went ahead to replace the value of u, which is ln x, into the equation to the power negative 2 over 2. Okay. So now we need to take the limits of this function as 1 over ln x squared tends to infinity. Now I just changed the annotation. It actually means the same thing. If you have a power of minus 2, it's the same as bringing it as a fraction, right? So we have to find this limit as it turns to infinity. So as you can see, the limits of this natural log would be 0. But let me explain. Let's say you take the natural log of 1. It's 0, right? If you take the natural log of 2, it increases to a certain number. Then if you take the natural log of, say, 9, it still increases. Now the denominator is increasing, especially as you're going to have to square it. The bigger the denominator gets, the smaller the whole expression is going to be. If you take 1 over a very large number, it's going to go closer to 0 than otherwise, if you do otherwise, right? So that's why the limit as this function turns to infinity would be 0. And now we just need to find the same function, but this time around replacing x with 2. So we're going to have negative of 0 minus ln 2 to the power minus 2 over 2. And the negative of a negative is a positive, so our final answer will be 1 over 2 ln 2. Okay, it was supposed to be ln 2 all squared. That was a slight mistake. So it's supposed to be 1 over 2 ln 2 all squared. Question 56. We have the integral of 1 over e to the power x minus e to the power minus x dx. We are going to let x be equal to the natural log of u. Now we are letting it to be the natural log of u because we want the e to the powers to cancel out. So if you have the natural log of u to be x, dx would be 1 over u du. Okay, we go ahead and substitute this into our equation, and we'll see that we have 1 over e to the power natural log of u minus e to the power minus natural log of u. So now this would be 1 over e to the power ln u minus e to the power ln 1 over u dx. Now we're going to substitute the x eventually. So this would give us 1 over u minus 1 over u times 1 over u du. For the first part of the expression, we can find the least common denominator and subtract. So this would give us 1 over u squared minus 1 over u times 1 over u du. Now for the first part of the expression again, keep in mind that the u which is at the bottom would go to the top if you simplify the fraction properly, just like this. And the u would have to cancel out eventually. This would give us the integral of u squared minus 1, which is the difference of two squares, and which is 1 over u minus 1 times u plus 1. We've seen this in the first part of this video where we have the easy questions, and this will eventually give us the final answers as natural logs. So keep in mind, this expression is not being simplified. You need to find the partial fractions, which are 1 over 2 u minus 1 minus 1 over 2 u plus 1. I'm not going to explain into much detail because I have explained before. So integrating this would actually give us the natural log of u minus 1 minus the natural log of u plus 1. And then using now the rule of logarithms, we're going to have half natural log of u minus 1 over u plus 1 plus the c. Replacing the value of u again at the end of the day. Don't forget, I almost forgot. So you would have e to the power x minus 1 over e to the power x plus 1. There we go. Moving on to question 16. We have 17 to the power natural log of x. Okay, there are different ways in which we can write 17, which I'm going to show you. So we can let 17 be equal to e to the power ln 17. Keep in mind, we're always trying to get rid of the natural log, so we need to use e. Okay, now in this case, if we replace 17 with that value, you see that in indices we have natural log of 17 times natural log of x. This would be interchanged just like this, so that ln of 17 goes outside because it's just a number, right? So we have now e to the power natural log of x times natural log of 17. E to the power natural log of x is just x, so we're going to have x to the power natural log of 17. Don't forget, natural log of 17 is a number, so we're going to have to add 1 to it and divide by the new value. So our answer would be x to the power natural log of 17 plus 1 over natural log of 17 plus 1. 1 is actually the same as natural log of e, isn't it? So if I rewrite this, I'm going to have x to the power natural log of 17 plus natural log of e, so that I can use the rule of logarithms, right? When you add two logarithms, you actually multiply their values. So this would be the natural log of 17 times e over the natural log of 17 times e, and we get x to the power natural log of 17e over natural log of 17e plus c. Okay, a lot of manipulations going on, but then it's good. Question 61. We have the integral of x squared over square. Question 68. Integral of x e to the power negative x squared. We can see that that power is actually interesting. If you derive it or differentiate it, it will give you x. So if we let u to be that power, negative x squared, then du by dx is negative 2x. Then we substitute this back into the equation. We're going to have x e to the power negative x squared times du over 2x. And definitely the x's would cancel out, just like I said before. Okay, now we're gonna have to take out the constant, which is -1/2, like this, and we have to integrate e to the power u du, easy peasy, and we will get -e to the power u over 2 plus c. Replacing the value of u again, you have -e to the power x squared over 2 plus c. Question 80. We have the integral of natural log of x squared plus 1. If we look at what's in the parentheses, we have x squared plus 1, right? If we differentiate that, you would have a 2x, but then there's no x attached to the question with which we can, easily substitute and cancel it out. So let's rewrite the question as 1 times natural log of x squared plus 1 dx, so that if we use integration by parts, when we integrate the 1, we're going to have an x to which we can affiliate the derivative of what's in the parentheses. Okay, so if u is natural log of x squared plus 1 and then dv is 1, that means v will be x and du by dx is 2x over x squared plus 1. Substituting these into the formula, we're going to have our integral being equal to x natural log of x squared plus 1 minus x times 2x over x squared plus 1. Okay, that's interesting. The numerator will come to x squared over x squared plus 1. And keep in mind, there's 2 ways we can simplify this polynomial fraction. We can use long division method because the degrees are the same. It's 2x squared and x squared in the denominator. You can use long division. You can actually rewrite this as 2x squared plus 2 minus 2, right? So that you can factor out 2. When you factor out the 2, we're going to have x squared plus 1 that will cancel out, and then we now separate each integral. So this would be 2 minus 2 over x squared plus 1. Okay, now we're forced to integrate this. We're going to have 2x plus 2 tan inverse of x, and our final answer will be xlnx squared plus 1 minus 2x plus 2 tan inverse of x plus the c. Okay, we have the integral of x cubed ln x dx. So with this, we're going to take dv to be x cubed. So in that case, its derivative is 1 over x, and v is x to the power 4 over 4. Replace into the formula for integration by parts, we would have x to the power 4 over 4 ln x minus the integral of x to the power 4 times 1 over 4 times x. Now some of the x's will cancel out nice and neatly. We're going to have x cubed over 4. And to integrate x cubed over 4 is not hard. It will just be x to the power 4 over 4, which multiplies to give us 16. So our answer is x to the power 4 over 4 ln x minus x to the power 4 over 16. Question 95. We have the absolute value of 1 minus e to the power x minus 1. Now this question is different. We can do it 2 ways. We need to get the absolute value function of the function itself. So when it's negative and when it's positive. So case 1, when x is greater than 0, what do we have? We have the function 1 minus e to the power x minus 1 dx. Integrating 1 gives us x, and integrating e to the power x minus 1 gives us e to the power x minus 1, right? Plus c. That's the first case. And case number 2. When x is less than 0, we would have the negative of this function, which is negative 1 times e to the power x minus 1. This gives us the integral, which is negative x plus e to the power x minus 1 plus c.